So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button.
Hello friend, in today's session we will learn how we can design and develop OTP based door lock control system by using Raspberry Pi, keypad, I2 sensor, GSM model, servo motor and IR sensor. So before start the next part, I would like to tell you I will cover the complete hardware connection of this project in this video. Also I will explain each and every part of the program. So I request you please watch this complete video so that you can design and develop this project by yourself. I will also share the code of this project. You can download the code of this project from my website link. The website link given in the description. The code is free, no need to pay any single rupees. You can design and develop this project by yourself. Just watch my video and follow the process. Okay, before start the next part, I would like to tell you what will be the flow of this project. So you can see on the screen we have the keypad, 4x4 keypad. Then we have the IR sensor. Then we have the servo motor. Then I2C LCD. Then GSM 900A model and Raspberry Pi 3B plus. You can use Raspberry Pi 4 also, there is no issue. You can use Raspberry Pi 3B plus also, there is no issue. You can use any Raspberry Pi for this project. The flow of this project is like that. When you give the power supply to the Raspberry Pi, then on the LCD it will show OTP based door lock system. The project name it will show on the LCD. Then after that, when someone come in front of this IR sensor, then here it will show enter the password. Okay, then password will generate random 4-digit password each and every time. Okay, so that password will send to the user mobile number by using this GSM model. Okay, so user has to enter that password within the given limit of time. So time is 10 seconds. So within 10 seconds, if user enter the correct password, then and then only the servo motor will open the gate and close the gate after some time. If password is wrong, then on the LCD it will show wrong password. If password, let's say if password is generated and within 10 seconds, the 10 second is expired. So password will be expired after the 10 second. Then again someone has to come in front of IR sensor and then again new password will generate. Each and every time new password will generate. It is a random password and random password will be sent from the GSM model on the user mobile number. Okay, so real time you will get the password on the mobile number and then by using that password you have to open the gate. So that is the complete flow of this project. I hope you understand the complete flow of this project. Now we will see the practical demonstration of this project and then we will see the hardware connection and program part of this project. So please watch this complete video. Okay, now let's see the practical demonstration of this project. So once I again run the project. So once I run the project, you can see on the LCD it will show OTP based door lock system project name on the LCD. Now once I come in front of this IR sensor, then OTP will generate. So you can see this is the mobile where we will get the OTP. So right now there is no OTP from me. So once I come in front of this IR sensor, then OTP will generate. So I come in front of IR sensor, you can see hand is there. So enter password, wait for some second, OTP will generate. Here you can see OTP generated 8788. Okay, so first we will see expire the OTP concept. Okay, now I will not enter the OTP here. So wait for 30 seconds. You can modify that second also, the timing. Okay, how to modify that I will explain later. So wait for 30 seconds, it will show OTP expire. you can see OTP expire. So that means if anyone do not enter the OTP with in specific time, then it will show OTP expire. Okay, now we will see the second condition, that is once someone come in front of IR sensor, again OTP will generate, but it will enter the wrong OTP. Okay, so again you can see currently we have only one OTP from this mobile, sorry, two OTP already I have tested one, and second one is 8788 that we just receive. Okay, now I will come in front of this IR sensor. Okay, enter password, again it will ask for the OTP. So OTP receive 4109. Okay, so I will enter the wrong OTP here, 410, let's say 5. So you can see wrong password. Okay, that is showing wrong password. So again we will come, so again I will show you the third condition if someone enter the correct OTP. Okay, so once again I will come in front of this IR sensor. OTP, enter the password, again new OTP will generate 4873. Okay, this time I will enter the correct OTP, 4873. You can see correct password, door open, then wait for some second, door close. So this is the idea. Now let's assume that, let's say again someone come in front of IR sensor. Okay, again enter password. So here again new OTP will generate 1940. So again we will try 1940. Correct password, door open and door close. So if someone again come in front of this IR sensor, so wait for some second, you can see it will show the OTP expire here if someone do not enter the password, OTP expire. Okay, so meanwhile I can tell you, each and every time you will get random number of OTP. Each and every time you will get the different OTP. Okay, you can see 9707, 8788, 4190, 4873, 1940, 1691. Each and every time you will get the different number of OTP. Okay, and that 4 digit will expire in 30 seconds. So I hope you understand the complete idea about this project. Now we will see the hardware connection of this project, and then we will see the programming part of this project. So please watch the complete video. Okay, now let's understand the hardware connection. So I am using Raspberry Pi 3B Plus board. You can use any Raspberry Pi, but I prefer Raspberry Pi 3B Plus board. I have ordered this board from my from Amazon, so you can order this from the Amazon. Also, how to flash, you need the OS software inside this Raspberry Pi. You need the OS for inside this Raspberry Pi. So how to install that OS I have already explained in my previous video. The video thumbnail you can see on the screen. Also you can check my playlist to check that video. Okay, also video link given in the description. Okay, so this is Raspberry Pi 3B Plus. Then here you need this paper, so you can design this paper by yourself. Because of this paper you can give the number, on this paper you can give the number like this. You can see 1 2 3 4 5 6, so that I can easily identify the pin number of this Raspberry Pi. Okay, so 1 3 5 7 odd number comes here and even number comes at this side. Okay, so easily you will identify the pin number while I am telling the connection. Okay, then connect your HDMI cable to Raspberry Pi first. Here this is HDMI cable coming from the your monitor, TV monitor. Then another circuit you need, this simple circuit. You can use the breadboard also, there is no issue. You can use the 0 PCB. So this is very simple circuit which having the common VCC and common ground. So whenever I need the VCC pin, I will take from here, that means 5V supply, and whenever I need the ground, I will take from here, because Raspberry Pi having the limited power supply pins. So we will design the so I have designed this circuit. By using this circuit I can easily take the power whenever I need it. So this is very simple circuit. You can see only solder I have done in the column. You can see this is the first column, this is the second column, and all pins are shorted. So you can use the breadboard also, there is no issue. Okay, so first I will place here. Then next pin is power pin. So fourth number pin of Raspberry Pi is power pin. So how to identify the pins number, what is the use of pins? You need the GPIO library in Raspberry Pi. So how to install that GPIO library, that I have already explained in my previous video. That summary you can see on the screen. Please install the GPIO library in your Raspberry Pi. Also in this video also I will explain. So if you don't want to switch that video, no need to switch. You can later we can see how to install that library. So from GPIO read all command you will get all this pin number information. So fourth number pin act as a 5V supply. So fourth number pin we will use as a 5V here. Plus means our 5V. Okay, so 5V pin is here, common 5V. Then 6 number pin is ground. So 6 number pin I will take from here. Then this should be connected to the ground. Okay, common ground, common VCC. So we have two pins now, common VCC and common ground from the Raspberry Pi. Then after that we need the LCD module. So this is the I2C LCD. You can purchase this from the Amazon again, there is no issue. Link given in the description, or you can search on the Amazon. So this I2C module, I have the separate video. Please watch that video, it is very important to watch that video. In this video I will connect this quickly. Okay, so this I2C module having 4 pins, SDA, SCL, ground and VCC. Okay, first connect the SCL pin from this I2C module to 5 number pin of Raspberry Pi. Okay, then SDA pin from this I2C module you should connect to 3 number pin of Raspberry Pi. Then after that VCC pin from this I2C module should be connected to our common VCC point, and ground pin should be connected to common ground. So very easy and very simple connection. For detailed understanding of this I2C module, please watch my I2C video. Okay, so once you connect I2C LCD with Raspberry Pi, now next connection is this keypad. So this keypad is very easy. First 4 pins act as row pins, R1, R2, R3, R4. Then next 4 pins act as a column pins, C1, C2, C3 and C4. Okay, so very easy connection. Okay, so very easy connection. You have to just connect one by one. So first pin you should take, this is the R1 pin. So R1 pin start from this star, you can see star, this is the R1 pin. Okay, R1, R2, R3, R4. So R1 pin should be connected to 29 number of Raspberry Pi. So 29 number of Raspberry Pi is here. Okay, then R2 pin should be connected to 31 number pin of Raspberry Pi. All this pin connection already given in the program. So while explaining the program I will tell you where you can find the pin connection. So R2 pin connected to 31 number. Okay, R1 we have connected to 29 number, R2 we connected to 31 number. Then R3 we connected to 33. Then R4 should be connected to 35. Okay, so next is C1 pin. C1 should be connected to 36 number pin. 36. Then C2 should be connected to 37. Okay, then C3 should be connected to 38, and C4 should be connected to 40. Very easy connection. Okay, you can take the screenshot of this connection. R1 is 29, R2 is 31, R3 is 33, R4 is 35, C1 36, C2 37, C3 38 and C4 40. Okay, so with this one we have connected our keypad with I2C module. Now next hardware is IR sensor. IR sensor again easiest one hardware, only 3 pin is there, VCC, ground and out pin. So another important point I should tell you here, you should calibrate this switch. Okay, so how to calibrate that I will tell you later. Okay, first connect the hardware. So first connect the VCC pin, VCC to common VCC. Already we have taken common VCC. Then ground to common ground. Okay, so this is my VCC, this is my ground. So VCC should be common VCC and ground to common ground. Ground also coming here to the common ground. Okay, so both pin are connected. Then output pin from this IR sensor should be connected to 7 number pin of Raspberry Pi. So 7 number pin of Raspberry Pi. So you can take the screenshot. Output pin we have connected to 7 number pin. You can see here IR sensor pin 7 number. Okay, so in this way IR sensor completed, very easy circuit. Now next is servo motor. Servo motor again simplest one, only 3 pins are there. So color coding is very important. Okay, so black color means ground, red color means VCC, and yellow color means this one output pin. Okay, so servo motor connection now. So first connect the black color means the ground. Black or brown color, you can see that is the color for this pin. Okay, brown or black color. So brown or black color, that means ground. So in your case, if there is a black, you can connect to the ground. If there is a brown also, that should connect it to the ground. Okay, then red color means the VCC 5 volt pin. So red color is 5 volt. Then last pin, that is the yellow color means the orange pin. Yellow color means the output pin, and that should be connected to 15 number pin of Raspberry Pi 15. In this way we completed the servo motor connection. Now next connection is the GSM model, that is the last one. So GSM model, very simple connection. You can see here we have to just use the ground pin and RxD pin. Okay, so first connect the RxD pin of the GSM model to 8 number pin of Raspberry Pi. And then the ground pin of the GSM model should be connected to common ground. So ground pin is connected to common ground. Okay, so I hope you understand the complete hardware connection. It is very easy connection of the GSM model also. Just we have connected the RxD pin of the GSM model to 8 number pin, and ground pin we have connected to common ground. So in this way we completed the hardware connection. Now I will give the power and we will see whether it is working or not. Okay, once you connect all the hardware, it is very important how to provide the power. So first you need the power supply for the GSM model, 12 volt 1 ampere. Okay, so this power supply you need. So first you place your SIM card here. Okay, place SIM card here and then provide the power to the GSM model. First you have to provide the power to GSM model. Then another power supply you need for the Raspberry Pi. You can use any mobile charger which having 5 volt 2 ampere rating, and that should be connected to Raspberry Pi power pin here. Okay, so this is the my mobile charger. You can use any mobile charger, you can connect here. Okay, now the third pin, you can see this is the HDMI pin. It is coming from the my TV screen. You can see this TV screen I have connected. You can use any TV screen which having the HDMI facility. So only this connection you need external. Okay, now as I said, first provide the power supply to this GSM model. Do not provide power supply to Raspberry Pi. So I am providing a power supply to GSM model from this adapter, 12 volt 1 ampere adapter. Okay, wait for some second. You can see the LED start blinking here. This network LED should stop blinking after 2 seconds. Okay, if it's blinking quickly, that means there is a no range. Okay, if it start blinking every after 2 to 3 seconds, that means there is a range on this GSM model. Then check whether here at this place whether your GSM model gets hits or not. If there is a hitting, that means your GSM model is faulty. Then you can give the call on this GSM model. If that call is getting, that is if you find the ring on your mobile, that means this GSM model having the network. So that all these preconditions you should verify first before giving power supply to Raspberry Pi. Now give the power supply to Raspberry Pi and your TV screen. It is very important before giving the power supply to Raspberry Pi and TV screen, you should first verify all your VCC and power pin. Okay, so your ground and VCC pin should be connected properly. So first check whether 4th number pin of your Raspberry Pi, it is connected to common ground or not. Yes, it is connected. Now 6th number pin of Raspberry Pi, this one, it is connected to common 4th number pin should be connected to common VCC, and 6th number pin should be connected to common ground or not. Yes, it is connected at mind. Then ground pin from this LCD module and VCC pin. So this is the ground pin from this LCD module. This is the ground pin from this GSM also. So ground pin from this GSM should be connected to common ground. Yes, connected. LCD common ground, it is connected to common ground. VCC to VCC, yes, connected. Then VCC and ground pin from this IR sensor should be connected to properly. So it is very important to verify your power supply. So VCC pin to VCC, yes, correct. Ground to ground, yes, correct one. Okay, then ground pin from this servo motor should be into ground, yes, correct, and VCC pin from this servo motor should be VCC. Okay, so at my end power supply is okay. Now I can give the power to Raspberry Pi. Okay, so you can see LCD showing the do not show any message because I haven't started the program yet. My screen start working. You can see Raspberry Pi screen start working. You should have the OS pre-installed in your Raspberry Pi. So how to install the OS in Raspberry Pi I already explained in my previous video. Please watch that video. Thumbnail you can see on the screen. Link given in the description, or you can check my playlist. Okay, then after that I have to run the program. So how to run the program, that I will explain later. Just focus here. Once I run the program, it will show the LCD name, project name on the LCD. So I run the program. You can see OTP-based door lock system. Now let's assume that someone come in front of this IR sensor. Enter password. If I enter the wrong password, door not open. Someone come again in front of IR sensor. They enter password, wait till password expire. OTP expire. Okay, now we will see whether OTP is sent on the mobile or not. So let's assume that someone come in front of this IR sensor. Enter a password. Now we will see whether OTP receive or not. You can see OTP receive 5160. Again I will come in front of IR sensor. So let's assume that again OTP receive or not. 1325. So let's 1325. So correct password, door open, door close. So in front of you I have connected all the hardwares. I run the program, it is working perfectly. So you can watch my video, definitely you can run this project. Now we will see the programming part of this project. Okay, let's understand the programming part of this project. So very important point is you should download this folder from my website link. The website link given in the description of this video. Okay, so once you download, you will find the zip file. You have to unzip that one, and then you will find this folder. So inside this folder you can see there are 3 files. You can see these 3 files. So first file is keypad. So if you want to just check the keypad with your Raspberry Pi, you can use this file. And if you want the project code, then project code is inside this file, OTP-based door lock system. Okay, and third file is command one. So this command file is very important. We have to install some command in your Raspberry Pi. So how to install that command, that I will explain. So right click on this command file, click on text editor. Okay, once that command file open, you can see these commands you need to install in your Raspberry Pi. So how to install this command? Just go to the Raspberry Pi terminal. So this black terminal is very important. Just open that terminal and copy one by one command. This first command you can copy this, right click, copy and paste and press enter. So I already installed this command in my Raspberry Pi. So once I press enter, then it will show command already installed or package already available. So this like reading package done, some package is already done. You can see I2C tool is already newest version, that is installed. So this command one by one you have to copy all the command one by one from here. Copy this, like second command, copy this and paste and press enter. Press enter, then second command will install. Then like third command, then fourth command, then fifth, then fifth, 1 2 3. This number is here wrong, you can ignore that number. First command, second, third, fourth, this fourth one, this fifth one, this sixth one, then 7, then 8, then 9, then 10, 11 and 12. So all this command you have to install one by one in your Raspberry Pi. So last command, this is used to detect your address of your I2C module. So just copy this command, and if your LCD is connected to your Raspberry Pi, I already explained the hardware connection. So if LCD is connected, just go and paste this command and press enter. So you can see 27 number, this is my LCD address. If this LCD address is different at your end, then you have to change the code, that I will explain later. If it's 27, there is no issue. Okay, so all this command you have to install one by one. Now once you install the command, then open the program. So go to this folder and then open this program, keypad with Raspberry Pi. Right click here, open this program, OTP-based door lock system. Right click on this program, click on Sony. Okay, so this program will work on the Sony browser. So you can see now I will explain importance of each and every line from the code. So first line is import raspberry pi.gpio. This is basically GPIO library which is used to access the GPIO pin of Raspberry Pi. Then time library, then character library that is used for LCD library that is used for LCD. Then random library that is used to generate the random OTP number. Then serial library, it is used for the serial communication. Also yes, from the serial I forgot one thing that I should tell you. Just you have to enable the serial communication of your Raspberry Pi. So how to enable the serial communication and I2C communication of Raspberry Pi? Just go to this Raspberry Pi configuration, preferences and configuration. Here it is very important to enable this configuration before use this program. Okay, then you have to go to the interface, and here you can see I2C I have enabled, serial port I have enabled, and the serial console I have enabled. Okay, so you have to enable all this and click on OK. So once you click on OK, you can reboot your Raspberry Pi, then that will enable, right, I2C and serial communication will enable in your Raspberry Pi. So that step also very important. Threading is actually library which is used to like we have that OTP expire after 30 seconds. Okay, so that 30-second timer should be play in the backend when your program is running. So to run that program in backend, we use the threading method. That's why we use this threading library. Then Pi GPIO library, it is used for your servo motor specifically. Then OS library, it is used for to run some OS command. So those are library very important. Okay, now next line is OS system sudo Pi GPIO library. So basically this is used to run this library in the backend. That's why this command is there. Then GPIO, we are using the Raspberry Pi as a board, so that's why this library. Then warning, we have to give the false. Then baud rate for our GSM model 9C00, we are using this GSM serial port TTSY0. Then I2C LCD, some configuration are there. This address is very important, 27. If your address is different here for this command, then you have to change this address to 27 to as per your address. Okay, then LCD clear. Then you can see our connection is there, R1, R2, R3, R4 keypad row pin, then keypad column pin are connected with this pin number of Raspberry Pi. Then IR sensor pin will be connected to 7 number. servo motor pin 22 number, but it is connected to 15 number. 22 number is BCM pin number, but board number is 15, so that's why you can see here 15 I have mentioned. Then keypad press, this is some variable that I will explain later. Then GPIO setup, basically all the pins we have to set as output pins, and some IR sensor pin we have to set as the input pin. Then column pins we have to set as the input pin, that's why all the configuration done here. Then this is for our servo motor configuration, so these 3 lines for servo motor configuration. Then some functions are there that we see later. Our main code will start here while 1. Our main code is start here while 1. You can see first clear the LCD, then OTP based door lock system name display on the LCD screen by this line. Then we are checking whether someone come in front of IR sensor. If it's come in front of IR sensor, then value is 0. Then person detected 1. Then generate the OTP. Then this function will call generate OTP. Generate OTP. Then random number of OTP will generate. Here you can see it is written that number. That number gets stored into this variable secret key. Then send function will call, and this send function will send this secret key. So send function here. So this send function will call with secret key. Some AT command will fire on this mobile number. So here you have to change your mobile number. So let's say if you want to change your mobile number, then you can just erase this number, only erase the mobile number. Okay, do not erase anything. So erase this number, plus 91 is country code. Then you can type your mobile number like this. Okay, do not erase any backslash, any double colon, only erase the mobile number. Then time.sleep, some AT command will send, and your message that OTP will send by this send function. Okay, on this mobile. Okay, then your countdown counter will start. It will count the timer. So this function will call in the backend. This function will call in the backend. You can see this 30 means 30 second. If you want to 10 second here delay, you can use the 10. It will give the 10 second delay. Okay, so this is the time down counter will start in the backend. It will start decreasing the counter 10, 9, 8, 7 like this. Then after that you can see person detected. If IR sensor detected, that means 1. Then keypad press, if any key is pressed. Let's say if you continuously press the 4 number key continuously, then it will only detect one time, only 4. That's why that logic is here, to detect press only one time. Then here it will identify whether your key is pressed by 4 times, because it is 4-digit OTP. That's why here 4-digit OTP. Then here it will check which key is pressed by using this read line function. Then countdown active. Let's say if your countdown counter is threshold gets over, 10 second gets over, then this function will call and it will show. Then if your timer is elapsed, then it will come inside this function. It will show OTP expire, regenerate OTP. And let's say if your secret key is matched, enter secret key is matched, then here it will come, it will print correct password, door open. And if the key is not matched, then it will show wrong password, please try again. So it is very simple and easy code. I hope you understand the code. And this logic, read line logic, is basically used to detect which key is pressed, and that once you press the key, that key is stored into input variable. And here you can see we are checking whether our input variable is secret key or not. So this is very simple and easy. I hope you understand the complete code. Now we will see how to run the code. So okay, now let's see how to run the code. It is very simple. You have to just click on this run button. Then you can see this message. You can ignore that message, and your code start working in the backend. Once I press you can see, once I place the hand in front of IR sensor, then message send, that means message send on your mobile number with this OTP. This is for your reference which OTP generated. You can also see on this terminal, also on GSM message you will get the OTP, and also your LCD start showing project name. You can see, I can show you that one. You can see it is working perfectly. So in this way you can run the project. I hope you understand the complete project, how to run the project, programming part of this project, hardware connection. If you like my content, click on like button, Please subscribe my channel. Please support me. Thanks for watching this.